Linear programming. A widely used mathematical modeling technique designed to help managers decide how to make the most effective use of an organization's resources. Objective function. A mathematical statement of the goal of an organization, stated as an intent to maximize or to minimize some important quantity such as profits or cost. Constraints. A restriction on the resources available to a firm. Certainty. The number and objective and constraints are known and do not change. Properties of all linear programming problems. 1. They have an objective function. 2. They have constraints. 3. There must be alternative courses of action to choose from. 4. The objective and constraints must be expressed in terms of linear equations. 5. Conditions of certainty exist. 6. Divisible. 7. Nonnegative variables. Steps in formulating a linear program. 1. Completely understand the managerial problem being faced. 2. Identify the objective and the constraints. 3. Define the decision variables. 4. Use the decision variables to write mathematical expressions for the objective function and constraints. Product mix problem. A common linear programming problem involving a decision as to which products a firm should produce, given that it faces limited resources. Profit contribution. Selling price per unit, variable cost per unit. The profit that the firm seeks to maximize is based on the profit contribution per unit of each product. Graphical procedure. Useful only when there are two decision variables in the problem. Nonnegativity Constrainst. A set of constraints that requires each decision variable to be non-negative. Each x must be greater than or equal to 0, t0 and c0. Inequality. A mathematical expression containing a greater than or equal to relation or a less than or equal to relation used to indicate that the total consumption of a resource must bear some limiting value. Feasible region. The area satisfying all of the problem's resource restrictions, the region where all constraints overlap. Feasible solution. A point lying in the feasible region. It is any point that satisfies all of the problem's constraints. Infeasible solution. Any point lying outside the feasible region. It violates one or more of the stated constraints. Isoprofit line. A straight line representing all non-negative combinations of x and y for a particular profit level. Corner point method. The method of finding the optimal solution to a linear programming problem by testing the profit or cost level at each corner point of the feasible region. Slack. The difference between the left-hand side and the right-hand side of a less than or equal to constraint. Often this is the amount of resource not being used. Slack equals surplus. The difference between the left-hand side and the right-hand side of a greater than or equal to constraint. Often this represents the amount by which a minimum quantity is exceeded. Surplus equals binding constraint. A constraint with zero slack or surplus for the optimal solution. Non-binding constraint. A constraint with a positive amount of slack or surplus for the optimal solution. Infeasibility in LP problems can occur if constraints conflict with one another. Unboundedness in LP problems. When the profit in a maximization problem can be infinitely large, the problem is missing one or more constraints. Redundancy in LP problems. One or more constraints that does not affect the feasible solution region. Alternate optimal solutions in LP problems. A situation in which more than one optimal solution is possible. It arises when the slope of the objective function is the same as the slope of a constraint. Integer programming. A mathematical programming technique that produces integer solutions to linear programming problems. Types of integer programming. Pure integer programming, mixed integer programming, and 0-1 integer programming. Pure integer programming. Cases in which all variables are required to have integer values. Mixed integer programming. Cases in which some, but not all, of the decision variables are required to have integer values. Zero-1 integer programming. Special cases in which all the decision variables must have integer solution values of 0 or 1. Enumeration method. Listing all feasible solutions and selecting the one with the best objective function value.